Okay, let's do a review of how exponents work with polynomials. All right, so recall that the English description of what an exponent is, we call this the base, we call this the exponent. We say this number multiplied by itself this many times. So in the case of 3 to the power of 4, it's 3 multiplied by itself 4 times. And what that looks like is 3 times 3 times 3 times 3, which comes out to 81. This is not the same as 4 to the power of 3, which is 4 multiplied by itself 3 times, which would be 4 times 4 times 4, which I believe is 64. Okay, so these two things do not equal each other, and it's important that you think of the English equivalent when you're working with these. Let's say we have 3 to the power of 4 times 3 to the power of 2. How can we combine these? So, actually, we're going to do it counterintuitively. Let's break it apart. So 3 to the power of 4 means 3 multiplied by itself 4 times. And 3 to the power of 2 means 3 multiplied by itself twice. And since they're all being multiplied, we really don't care about these parentheses here. So now if we're just looking at it, how many times is 3 being multiplied by itself? 1, 2, 3, 4, 5, 6. So we can simplify this to 3 to the power of 6, because 3 is being multiplied by itself 6 times. So what happened to the exponents here? The exponents got added together. So this is the same as 3 to the power of 4 plus 2, which is the same as 3 to the power of 6. So when we have the same base, so the base is the big number, when we have the same base being multiplied by itself, we add the exponents, okay? When we're multiplying, we add exponents. Let's take a look at another example. Let's say we have x to the power of 3 times x to the power of 1 times x to the power of 5. How can we simplify this? So we all have the same base. It's all x, so we can combine it into one term. How many x's do we actually have being multiplied? We have 3 here, we have 1 here, and we have 5 more here. So 3 plus 1 plus 5 gives us x to the power of 9. Okay, so this is just a way to simplify our terms into one base. Simplify our different, you get the idea. Now let's say we wanted to combine all these together. So let's just look at, see we have a coefficient, a x and a y in each of these parts. So let's just think of it one at a time. Let's look at the coefficients. We got 3 times 4 times 5, which gives us 60. How many x's do we have being multiplied? We have 1 here, 2, 3, 4, 5. So x to the power of 5. And then y's we have 1, 2, 3, 4, 5. Y to the power of 5. So when we're multiplying exponents, you just add the exponent. Now remember, what happens if we have x squared plus y cubed? Can we combine these at all? No, because remember, the rule for combining, which means adding or subtracting, the rule for adding or subtracting is they have to have the same base and the same exponent. So what we've just been doing, that's only for when we're multiplying everything. When we're adding, same base, same exponent. Now let's say we have this polynomial raised to the power of 2. You might think this is just going to be x squared plus 3 squared, but it's not. So remember, when we have this, the exponent out here means this multiplied by itself twice, so that's exactly what we're going to do. We're going to do x plus 3 multiplied by itself twice, and from here you just use the FOIL technique, and you would end up with that, I believe. So we still have the x squared and the 3 squared, but we would be missing a full other term in there. So this does not, you can't just throw the x, you can't distribute the exponent, okay? You actually got to multiply the base by itself. Okay. Now let's take one more look. Let's say we have 2 times x to the power of 3 all of this raised to the power of 4. Now, you might just think, oh, I just need to add exponents again. But no. Remember, when we have an exponent, we treat this as a base. We say this multiplied by itself 4 times. So that's what we're going to do. Okay, so this is what it breaks down to, and we can just do our coefficients. We got 2 multiplied by itself, 2 times 2 times 2 times 2, which is going to give us 16. And then we have x multiplied by itself. How many times is x being multiplied? 3, 6, 9, 12 times. X to the power of 12. So this is actually the same as 2 to the power of 4 times x to the power of 12. So if you notice, when we have an exponent outside of something else, we don't add it like we were previously. Each thing actually we multiply exponents is what I'm trying to say. So see how the 3 and the 4 multiplied to get 12? That's just a shortcut, but if you aren't comfortable with that, always just break it down. The base multiplied by itself this many times, just like I erased it already, but just like what we did right here. Always, until you get comfortable, just break it down. The base multiplied by itself this many times, x plus 3 times x plus 3, and you'll get the right answer. But so yeah, when we're multiplying in a line like this, that's when we add our exponents. 3 plus 3 plus 3 plus 3 gives us 12. When we have an exponent raised to an exponent, that's when we multiply. So just keep those things in mind. But like I said, if you just break it down the long way, you should be able to get it. Think about it in the English. You should be able to get it every time.